Welcome to this lesson video. Today we are looking at oxidizing and reducing agents. Let us start. Redox reaction is a chemical reaction which we emphasize oxidizing agent and a reducing agent. Now, in order for you to determine which element undergoes oxidation, reduction, we need the skills of calculating the oxidation numbers. There is a lesson video whereby we calculate the oxidation number, how to determine the oxidation number of an element inside a pure molecule or a compound. So we need those skills on how to calculate the oxidation numbers. Looking at the oxidation numbers, we can be able to tell whether an element undergoes oxidation, it's a reducing agent, or undergoes reduction, which is the oxidizing agent. Now, for example, let us look at this chemical reaction. We are reacting hydrogen and oxygen to produce H2O. And then we can see that the overall oxidation numbers, it's 0. So we don't know whether oxygen or hydrogen, actually we don't know whether oxygen undergoes a reduction or oxidation, or hydrogen undergoes oxidation or reduction. We need to calculate the oxidation numbers. Now for this one, we can see the oxidation number is simply 0. Then for this one, it's 0 because we have a pure compound. Actually, it's a pure molecule. It consists of only one type of an element. Now what we need to do, we need to calculate the oxidation number of each element in this compound. Now we can see that we have 2 atoms of hydrogen plus 1 atom of oxygen. It's equals to the overall, it's what? It's 0. So in this case, you can see that oxygen is not a metal. So it means the oxidation number of hydrogen, it will be 1. And then we are going to put X because we are trying to verify the oxidation number of oxygen. So we have 2 multiplied by 1, it's simply 2 plus X is equals to 0. X is equals to -2. So you can see that the oxidation number of oxygen in this case is 2-. And we can also verify this oxidation number by saying H2O is not a peroxide. In this case, we know that oxygen, when it's inside a peroxide, it becomes 1-. In this case, it's 2- because H2O is not a peroxide. Now for hydrogen we have 1+, and then for oxygen we have 2-. With this information, we can quickly determine our oxidizing agent and reducing agent. We are going to use a table just to summarize everything. So we have hydrogen and oxygen. Now what happens to hydrogen? The oxidation number of hydrogen from 0 to 1+, we can see that the oxidation number has increased. And then we look at the oxidation number of oxygen from 0 to 2-, the oxidation number has decreased. Now we know that the definition of oxidation in terms of oxidation number, it's an increase in oxidation number. So in this chemical reaction, we can conclude that hydrogen undergoes oxidation because the oxidation number is increased from 0 to +1. And then looking at hydrogen, not hydrogen, I mean oxygen, the definition of reduction in terms of oxidation number, it's a decrease in oxidation number. So it means this undergoes reduction. And then furthermore, we can see that since hydrogen undergoes oxidation, we need to understand the oxidizing and reducing agents. But before we get there, hydrogen undergoes oxidation, so we say it's oxidized. And then oxygen undergoes a reduction, we say it has been reduced. Now let us get to oxidizing and reducing agent. That is the core of this lesson video. We need to understand that redox, which is a reduction oxidation reaction, takes place simultaneously. So it simply means that when the other element undergoes a reduction, the other one simultaneously undergoes oxidation. Now, for example, in this chemical reaction, hydrogen undergoes oxidation. What causes it to undergo oxidation is the other element which undergoes a reduction. So let us say this: hydrogen undergoes oxidation. What is causing hydrogen to undergo oxidation? It's oxygen. So in this case, we say oxygen forces hydrogen to undergo oxidation. Now, elements which forces other elements to undergo oxidation, we say those elements are oxidizing agents. It's an agent that forces other elements to undergo oxidation. That is why we say it's oxidizing agent. Now, same goes to oxygen. Oxygen undergoes a reduction due to the enforcement of hydrogen. So hydrogen forces oxygen to undergo reduction. So we say hydrogen is a reducing agent. It's responsible for making other elements to undergo reduction. I hope you understand this term. Let us look at other examples. Example number 2. You can see that some of the chemical reactions are not balanced, but the core main aim for this lesson video is to look at reducing and oxidizing agent. So we look at this. We need to calculate the oxidation number of elements before I'm talking about the reactant side and the product side. So for the first compound, this one, we don't know the oxidation number of lead, which is Pb, but we definitely know the oxidation number of sulfur because it's in group number 6 on our periodic table. So elements in group number 6, we know that it's 2 minus. So we have X plus 2, actually it's negative 2, it's equals to, you can see that the overall charge of the compound is 0. So we have X minus 2 is equals to 0. We have X is equals to positive 2. Then we can conclude that, okay, sulfur is 2 minus, lead is 2 plus. That is the oxidation number. That is why I'm saying it's very important for you to watch the previous lesson video, whereby we look at only oxidation numbers. We look at the rules, we look at the periodic table, and then the oxidation number of oxygen on the reactant side, it's 0. It's actually 0. And then we need to calculate the oxidation number of lead and oxygen in this case. This is not a peroxide, so we definitely know that the oxidation number of oxygen in this case is 2 minus. Then let us quickly calculate the oxidation number of lead. So we have x plus is equals to 0. So it's x minus 2 is equals to 0. We have x is equals to positive 2. So we can see that the oxidation number of lead hasn't changed. So we have 2 plus. Now we need to look at this compound. Again, this is not a peroxide, so the oxidation number of sulfur, not sulfur actually, I mean, the oxidation number of oxygen will be 2 minus. So we have x plus 2, negative 2 is equals to 0, x negative 4 is equals to 0, x is equals to 4 plus. So you can see that the oxidation number of sulfur in this case is 4 plus. Then we need to compare the oxidation numbers. We can see that the oxidation number of lead on the reactant side is 2 plus, on the product side is still 2 plus, so lead didn't undergo oxidation or reduction. Now we look at oxygen. Actually, let us look at sulfur. It was 2 minus, and then on the right hand side it's 4 plus. So you can see that something happened. Look at oxygen. We have 0, then on the right hand side we have 2 minus. So you can see that we are comparing oxygen and sulfur. So from 2 minus to 4 plus, we can see that the oxidation number has increased. Then from 0 to 2 minus, the oxidation number decreased. From there we can conclude that this undergoes oxidation, this one undergoes a reduction. Then from there we can also conclude that this was oxidized, then this one was reduced. Then we say this is our reducing agent, then this one is our oxidizing agent. So we can say the element that undergoes reduction is an oxidizing agent. The element that undergoes oxidation is a reducing agent, I mean. This is our next example. Pause the video and determine which one is oxidizing agent, which one is a reducing agent. So in this case, we can see that this is not a pure molecule, so we need to calculate. So in this case, you don't know the oxidation number of carbon. So we have 4 atoms of oxygen. 1 atom is 1 plus. It's equals to the overall is 0. So x plus 4 is equals to 0. X is equals to negative 4. So we can see that the oxidation number of carbon is 4 minus. The oxidation number of hydrogen in this case is 1 plus. Now we know that the oxidation number of oxygen in this case is 0 because this is a pure compound, a pure molecule, I mean. Now we need to calculate the oxidation number of each element in this compound. Now we know the oxidation number of oxygen in this compound. This is not a peroxide, so it's 2 minus. Then we work out the oxidation number of carbon. So we have X plus 2 atoms, negative 2 is equals to 0. X minus 4 is equals to 0, and then we have X is equals to 4. So you can see that the oxidation number of carbon on the product side is 4+. We are left with this compound. Now we know that the oxidation number of oxygen in this case it's 2-, since this is not a peroxide, and then the oxidation number of hydrogen will be 1+. From the previous examples, we know that this will be 1+. Now we need to compare now. Looking at the reactant side, we can see the oxidation number of carbon is 4-. I'm talking about this. It's 4-, and then on the product side we have 4+. We look at hydrogen, it's 1+, still remained 1+, so this we cannot compare it. Now we look at oxygen, it's 0 to 2-. So you can see that we are going to compare two elements, so it's carbon and oxygen. Now you can see that carbon from 4- to 4+, the oxidation number is increased, so it means it undergoes oxidation, it's been oxidized, then it means this is the reducing agent. Then we look at oxygen from 0 to 2-, the oxidation number has decreased, it has been reduced, so this is the oxidizing agent. I hope you got this one correct. We look at another example. An element is 0, the oxidation number. Then from here we need to work out the oxidation number of each element in this. This is not a metal hydride, so it means the oxidation number of hydrogen is 1+. The oxidation number of chlorine, it will be 1-. In order for the overall oxidation number to be 0, we can quickly calculate this. X is for chlorine plus 1 atom of hydrogen, 1+, is equals to 0. So we have X plus 1 is equals to 0, X is equals to -1. And then looking at the product side, we need to calculate the oxidation number of these elements. We don't know the oxidation number of iron in this case, but we know the oxidation number of chlorine is 1- because it's a halogen. So we have X plus 2 minus 1 is equals to 0, X minus 2 is equals to 0, X is equals to 2. So we can see that the oxidation number of iron in this case is 2+, and then of chlorine is 1-, and then hydrogen is actually 0 because it's a pure substance, actually a pure molecule. We need to compare now. You can see that the oxidation number of iron is 0. On the product side it's 2+. Then we look at hydrogen. Hydrogen, it was 1+, now it's 0. We look at chlorine, it's 1-, it remains 1-, so we don't look at chlorine. In fact, we look at hydrogen and iron. So hydrogen from 1 to 0, the oxidation number has decreased, so it undergoes a reduction, a decrease in oxidation number. then this means this is oxidizing agent. Now look at ion from 0 to 2 plus, the oxidation number is increased, it undergoes oxidation, then this is the reducing agent. I hope you got this one correct. That's it for this lesson video. This is Bahula SJ. Thank you very much.